Welcome to AI Frontiers. Today's episode explores the reliability revolution in artificial intelligence, examining AI's shift from scale to trust. This synthesis of 27 papers from December 28, 2025 reveals a field moving beyond simple scaling to build robust, reliable, and responsible AI systems, from nuclear control to self-evolving scientific agents. Consider a nuclear reactor controlled by artificial intelligence. This high-stakes reality of modern AI systems involves AI making real-time decisions within a reactor core, where a single miscalculation could cascade into catastrophe. Recent research demonstrates a sanity collapse phenomenon, where a compact AI rejects risky behaviors learned during training, locking onto a single, demonstrably safe control strategy. This is not science fiction, it is from today's research frontier. The field of artificial intelligence is undergoing an identity crisis and evolution, moving beyond brilliant but brittle systems. The era of simply scaling models is ending. The new frontier focuses on robust, cumulative, and reality-grounded intelligence. This means building systems that verify what they know, not just know things, systems that master new tools and teach discoveries to others. The goal is to construct responsible partners, not just smarter tools. Picture the AI research landscape as a cityscape, evolving from skyscrapers to resilient neighborhoods. Massive foundation models are like towering but fragile skyscrapers. New development includes compact, fortified buildings designed for specific, high-stakes purposes. Multi-agent neighborhoods enable specialized units to collaborate, while shared libraries of knowledge act as public works projects. The entire city is growing smarter, more resilient, and more integrated. The first major theme is the rise of the self-evolving agent, marking a shift from static tool users to dynamic skill builders. A traditional AI agent is like an apprentice with fixed tools on the bench. A self-evolving agent, however, is the apprentice who forges new custom tools. The CASCADE framework enables this by allowing agents to autonomously master complex external software, codify that knowledge into executable and shareable skills, and build a cumulative library. This represents a move from disposable to institutional intelligence. The second dominant theme is a deep focus on robustness and reliability under pressure. Research is moving beyond polite quizzes to stress tests, simulating earthquakes and hurricanes for AI's epistemic foundations. Rahul Bakši's drill down and fabricate test probes knowledge by semantically compressing facts through multiple paraphrases and testing against adversarial falsehoods. Benchmarks like CubeBench isolate failures in spatial reasoning and long horizon thinking. The message is clear: brilliance is meaningless without bedrock reliability. The third theme is the structured grounding of imagination. This addresses the tension between unbounded AI creativity and the need for controllability and consistency. The solution is to build stages with firm rules. For instance, web world models use reliable web code to define immutable rules, like gravity and collision, creating a structured stage. Large language models then generate narrative and decisions within those guaranteed boundaries. This hybrid approach is also seen in the spiral planning system and knowledge graph models that fuse neural networks with geometric algebra. Key findings from the research read like mini-stories of breakthrough and revelation. In the CASCADE framework, enabling self-evolution mechanisms caused success rates on complex scientific tasks to jump from 35% to over 93%. The drill down and fabricate test revealed that epistemic robustness is almost completely unrelated to model size or architecture. The nuclear controller exhibited a dramatic variance collapse, stabilizing on a single safe strategy. Meanwhile, a reward model selection crisis showed that simple in-context learning often outperforms complex optimization for larger models. These findings redirect the field's fundamental priorities. The paper of the day is CASCADE, Cumulative Agentic Skill Creation Through Autonomous Development and Evolution by Huang and colleagues. This work proposes a new paradigm for AI systems, breaking the static tool use barrier completely. It enables agents to learn to master never-before-seen specialized software. The framework equips agents with two meta skills: continuous learning and self-reflection. This transforms the AI from a temporary consultant into a tenured colleague who builds on past success. CASCADE operates through a virtuous cycle of continuous learning through exploration. First, the agent hunts for executable knowledge in documentation, forums, and research papers. Second, it extracts and tests code snippets, like Python scripts. Third, it introspects, formalizing the successful process into a reusable skill package. Fourth, It stores this skill in a shared, queryable knowledge library. Fifth, the agent uses this growing library to plan and solve increasingly complex tasks, creating a self-reinforcing cycle of skill acquisition. The impact and implications of CASCADE are profound, charting a path toward AI-accelerated science. Evaluated on the SciScale bench of 116 materials science and chemistry tasks, it demonstrated transformative performance. It has real applications in computational analysis and autonomous lab experiment planning, and can even selectively reproduce parts of published scientific papers. This raises profound questions about ownership of AI-discovered skills and safety checking of autonomously acquired capabilities, forcing a reimagining of the entire scientific discovery process. Looking to future directions, a hopeful analogy can be drawn from the evolution of aviation toward cognitive avionics. Early aviation focused on more powerful engines, akin to AI's scaling era. True reliability came from integrated systems and rigorous protocols. The future of AI points to diagnostic systems running pre-flight checks on a model's knowledge integrity, specialized control systems with guaranteed stability for critical functions, and multi-agent air traffic control architectures orchestrating teams of specialized AIs to navigate complex problems collaboratively. In conclusion, the field of artificial intelligence is showing maturity, moving from an obsession with scale to a nuanced engineering discipline focused on building responsible partners. Self-evolving agents like CASCADE enable cumulative expertise. Stress tests, such as those from Rahul Bakshi and colleagues, reveal fundamental limits and redirect research. Specialized systems, like the nuclear controller, demonstrate safety-critical reliability. The journey from AI as a fascinating tool to AI as a responsible partner is well underway. The frontier is no longer just what AI knows, but what we can trust it to do. This presentation was created through AI synthesis and review. The content was synthesized using the GPT DeepSeek model, specifically DeepSeek Chat. Text-to-speech synthesis was powered by Amazon Polly. Image generation was conceptualized with Grok. All synthesized content was reviewed by a human expert. It is important to note that some oversights may still exist. All references to the 27 source papers are provided for further exploration. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from the archive preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses archive preprint server content under its API terms of use. AI Frontiers is not affiliated with or endorsed by the archive preprint server.